those of us that get it and enjoy it so much, because it's like, I don't know how to describe it. It's like being that little kid and you want to just go outside and catch frogs or catch snakes or see what's out there. Mm-hmm. You know, it's that curiosity that you could do as a kid, but for your career. You know, you can go out there and say, what is happening out there in the ocean, or what is happening on the marsh, and why is it happening? So you can still be that little kid trying to go out there and find things and answer questions, yet now it's your career. You get paid to do it.
I really like how science just makes sense to me, and once you go outside you can just see how it works basically everywhere in the world.
Everything is interesting. You can always learn something new, and even the most boring seeming creature can have something really cool.
I like the fact that it addresses questions as of why. A lot of fields don't answer why something happens, and they're content with just how it works. And science challenges ideas. I like the challenge, and it's something that doesn't become routine. There's never a routine in science. Everything's changing.
Just by observing and writing down what you observe, you come to realizations that you would never really have understood just by, I don't know, reading a text or something.
Well, they are all different.
I didn't really get much into physics.
Biology, I think, is very interesting because it is the study of life.
Biology definitely is easier for me, but
it's the study of living things, and I find them more interesting than numbers.
Chemistry might be my favorite.
I always thought I really wanted to do something with biology. I was going to go back to the Netherlands and study health science, but right now I'm figuring out that I'm actually not that interested in the biology basic stuff. I'm more interested in physics and chemistry than the biology part.
If I had to pick between physics and chemistry, I probably would pick chemistry. But then again, everybody has their own interests, and certain subjects that are supposed to be hard for people are not hard for people, and so it just all depends on how our brains work.
I love chemistry.
There's something about chemistry, even though it was always really tough for me, that just fascinated me, because you learn about the reactions and you learn about, like I was telling you about the calcium carbonate and the acid rain, and it's just observing things on such a small scale.
I think physics is more about the worldwide concept, what happens in the world. It's not just one cell in one organism that's different than another cell in another organism. It applies to something you can see outside, instead of if I look through a microscope and have a magnification of 10 million times, I can see this.
Knowing chemistry in general is something so valuable that if anybody plans on going to grad school with a science minor or major, you're going to have to know that.
Biology for me is the easiest, right? Biology is all about the life, so it's all about the organisms. So, I mean, for me, to go to a different ecosystem, I'm interested in the organisms that are there. If you then compare that with physical science, it's the laws governing the planet. So laws about energy, about motion, resistance. Yeah, there are three really different areas, which in hiring all the new science faculty, we wanted to make sure we had really strong scientists in all those three fields. The minor was launched in fall of 2008, and so now fall 2013, the major will be launched. So those are the years. But really, when we started thinking about and designing the minor, so right away, fall 2007 is when I started. That's when we started putting together ideas for the minor. So that was really the beginning of the minor and the major.
I think that everyone here really wants it to grow.
It's awesome.
They're very motivated, and that's how we became a major.
We're always encouraged to be involved, and they're so excited about the topic.
They're all really very committed.
We're going to be able to grow and become better.
We're always updated on what's going on within the department.
It definitely is going to take some work to build upon.
I think there is more work to be done, but still.
Wow, so our goals are huge, because it's not enough for us now to just have the program. It's got to be a successful program. The students have to come to Flagler seeking out this program. We have students who come to Flagler when we didn't have a science program. if we can get that kind of enthusiasm going outside of Flagler, we've now got it here. We can get that outside and really get students coming to Flagler. I think
Sky's the limit.
our options are just endless. We've just started.
And that's what's great about anybody who's coming in to this major, or even deciding to add it as a minor. It's that you're helping build upon this foundation that we already have for environmental science. And
They're passionate about it, which is another difference that I found between not all my teachers at my other school, but some of the teachers that taught a lot of the general courses were just there to kind of teach and do the job, whereas here they're really interested and they're prepared to learn as well.
I already know students that have gone to conferences with their work, so that's great to know that we're making that step in the right direction.
Flagler is finally getting a science major, and so the research that Dr. Terry Saran's class is doing now is really kind of setting the foundation for the next senior class to do molecular work. And molecular work really hasn't ever been done at Flagler College, and so it's really exciting to be able to say that we can do this, that the work that I've done, I've presented at conferences, and I'll go to conferences and people are like, Flagler College, they have science there?
Okay. Awesome. Did you get it? Do you need goggles?
I'm going to give a safety brief, and we do our risk assessment so that we make sure that
We need your gloves, the coat, and the goggles.
exactly.
You contaminated the second well.
Are we actually running it? Okay.
They don't need to know
Oh, that's what
They don't need to know what the nucleotides are. You don't need them. I don't care if they memorize. Do you really care that they memorize adenine, cytosine, guanine, thymine? They don't. It doesn't matter. Okay, these are four different bases. Okay, that can be altered by mutation.
Marine molecular field research.
Oh, well, that just sounds really interesting to me. It's marine biology, but you're looking at it at a molecular level. And when we look at something at a molecular level, it's more like cell processes,
It's something I would take.
protein synthesis.
Well, marine biology research would just be, I guess, about any living organisms within the marine ecosystem.
And so then you can see what's being expressed at a certain time, given the environmental stimuli.
But molecular would be more on a molecular level.
There isn't going to be a class on there that I wouldn't be intrigued with, and the professors here are very good at sparking their interest.
Aquatic chemistry.
I am really looking forward to take that class.
Sounds like it would be very hard.
I love chemistry. I love the ocean.
That would be really interesting considering we only know, I think it's like 5% of the ocean.
So that sounds like a really interesting course that combines both of them.
Aquatic chemistry. So this would normally be a Chemistry 2 course. But again, we've designed our major a little bit differently at Flagler. We want it to be applied environmental science. We don't want it to just be theories that you know to be book smart but don't make sense in the real world. So aquatic chemistry is all about the issues involved. It's a chemistry course where you're going to think about things like acid rain and what's the chemistry behind that. You know, what does acid rain mean to an ecosystem? What are the changes that are going to happen? So it's an issues-based course as opposed to sitting in a lab mixing acids and bases with the big goggles and the white coat. It's issues. What are the issues involved in the chemistry of our planet?
I pretty much go into any class not being able to really say like exactly what it is. But when I leave, it's like the meaning of that, what I just learned is like deeply rooted in me.
Really excited.
Extremely excited.
Really excited.
I'm extremely excited.
It'll be my first like hands-on research project where I'm doing research for what I feel is kind of like a bigger cause than just my education.
The fact that we're going to be staying on a boat is super cool, and the fact that we get to scuba dive every day.
We're gonna snorkel and dive a lot and look at the coral reefs and do fish count, just basically set up the baseline for future years that they're trying to like keep going there.
We're going to be collecting data, and they're going to go every year after this and build on that data so they learn the state of the ecosystem that we're studying.
Data is going to be contributed to the reef, and the reef is an actual agency which has a wider database which we're going to contribute to.
I feel like I'm actually contributing my own work to somebody else.
And I just want this semester to be over, summer semester to be over, and then just go out there and have an amazing time for 7 days.
It's going to be awesome.
Our Summer Bahamas program is going to be awesome. So last summer I got a chance to go and see it, and it is the most incredible crystal clear water you can imagine.
We're going to be on a boat, staying on a boat for the whole week.
This summer will be the first time that we're taking 12 Flagler students to the Bahamas for a week. We're going to be living on a boat the whole week, so you can't escape from the ocean.
We're gonna snorkel and dive a lot and look at the coral reefs and do fish count, just basically set up the baseline for future years that they're trying to like keep going there.
Every day, all week long, we're going to be doing research. So we're going to be seeing what's there, basically. Since this is a first trip, we're going to be laying down the baseline of what kind of fishes are there, what kind of corals are there. So what is the biodiversity? And then is it different island to island? So because we're on a boat, we're going to be traveling down to a lot of different islands, both inhabited and uninhabited as far as humans go. So what's there? Does it make a difference? Can we see comparisons, or can we make comparisons and see differences? So really we don't know what we're going to find. It's pretty much a real exploration to see what the health is. I mean, we don't know how healthy or how affected the coral reefs are.
And we're going to be researching the coral and the reef and the ecology of the reef. And I think that we're going to get into groups on the trip, and we're going to each be presenting like a little research project that we come up with while we're there.
I think you get a really clear view of what scientists who like wear a lab coat or like diving gear do in their like job, and I can really see if that's something I like.
I think it'll give me more experience in the field, and I'll be able, if I decide to do marine biology, I'll be able to say that I was on that trip and be able to show something for the work.
I think the Bahamas trip is going to benefit me in the fact that it's getting me out, and it's a time where I can actually reevaluate and see if I do want to work out in the ocean, maybe inspire me to, if there's a species that I find intriguing, to then look further into that. I think there's multiple ways that it can inspire and then also motivate me to move forward with my dreams.
It sounds cheesy, but it's kind of the opportunity of a lifetime.